So here we want to decide if functions are linear or nonlinear. And looking at this graph, seeing how it curves, because it curves like that, this is nonlinear because the graph curves and is not a straight line. Here, is this function linear or nonlinear? This is linear because the graph is a straight line. Is this function linear or nonlinear? This is nonlinear because the graph is not a straight line. Now this gives students some issues because this part of the graph is straight and then this part of the graph is straight, but they are connected right there and it turns. So because this is one big graph, not multiple different graphs, this is nonlinear because it turns. Which graph represents a nonlinear function? 1 and 2 are both nonlinear because those graphs are curved. They are not straight. Circle the table that represents a nonlinear function. So, in order to find a nonlinear function, we need to see if we can find the slope. I see I'm decreasing by 8, decreasing by 8, decreasing by 8, decreasing by 8. These are all doing the same thing. Plus 1, plus 1, plus 1, plus 1. These are all doing the same thing. Since both sides are doing the same thing, this is linear because you can find the slope. This is going up by 1, up by 3, up by 3, up by 2. Now these are different. That doesn't mean that this is nonlinear because we have to check both sides. If both sides go up different, there's a chance that they could still be linear, but since this side is doing the same thing and this side is doing different, this one is definitely nonlinear. And let's check this last one. Plus 2, plus 3, plus 4, plus 5, and I see that all of these are going plus 1, so this is the same. This is different, so this one is also nonlinear. Those are linear, or nonlinear, I should say, because we cannot find a constant rate of change. You can't find the slope, so it is non-linear. Is this table a nonlinear function? Let's see. Plus 1, plus 3, plus 5, plus 7. These are all plus 1. This is all the same. This is different. This is nonlinear because there is no slope or it is not increasing at a constant rate. So, there are 20 rabbits on an island, and the population triples every 6 months. Let's make a table, and let's try to find out how many rabbits there will be in 2 years. So in 6 months, the population triples. So that means there will be 60 rabbits in 6 months. In a year, again, the population triples, which means there'll be 180 rabbits after a year. And then a year and a half, 18 months, there will be 540 rabbits. And then in 2 years, 24 months, 1,620 rabbits. Is this linear or nonlinear? Explain. This is a nonlinear function because it does not increase at a constant rate of change. So we have to use the pattern above to see when the population will reach 1,000. So we started with 20 rabbits. It triples every month or every 6 months, right? And we want to know when it will reach 1,000. Sorry, 1 million. I was way off. So I get 5, I divide by that, I get 50,000. So and we're going by months here.
To determine if graph is a function.
So let's use this pattern to continue to see after how many years. So at 24 months, we're at 1,620. Then at 30 months, or 2.5 years, be 4,860. 36 months, 14,580, and 40 months, 131,220. Then in 46 months, 393,660 rabbits, and then in 50 months, we'll be at 1,180,908. So here's 3 years. Crap. That's where I messed it up. Start over. So in 24 months, or 2 years, 1,620. Then at 30 months, or 2.5 years, 4,860 rabbits. Then at 36 months, or 3 years, 14,580 rabbits. 3.5 years, or 40 months, would be 43,740. At 46 months, we'll be at 131,220. 50 months, or 4.5 years, will be at 393,660 rabbits. And then at 56 months, so 5 years, we'll be at 1,180,980 rabbits. So in 5 years, we'll reach that rabbit population. So, is this linear or is this one nonlinear? I see that I am going 2 years at a time over here, increasing by 2 years to go from 19,900 to 13,000. That is decreasing by 6,900. But then I am increasing by 1,100. Since this is the same and this is different, this is non-linear. And we cannot predict this bat population because the table randomly increases or decreases, and there is no pattern. There's no pattern to the table going on.